During the World War II, armies learned quickly that standard tents failed under sustained wind, heavy rain and wet snow. Poles snapped, stakes pulled free, and rigid frames transferred stress directly into collapse. In response, soldiers relied on a rope and canvas shelter method that treated wind and load as forces to be absorbed rather than resisted. It appeared simple, almost unimpressive, yet it endured storms that flattened conventional tents. This method did not depend on poles standing upright. It depended on tension, geometry and disciplined setup, and once established, it rarely failed. Field operations rarely allowed level ground, deep anchoring or dry soil. Rain turned camps into mud. Snow added weight overnight. Wind shifted direction unpredictably. Traditional tents relied on vertical poles to carry compressive load, which made them vulnerable to side forces. Once a pole bent or shifted, the entire structure followed. World War II engineers and field manuals recognized that collapse was not caused by canvas failure, but by rigid framing that could not adapt. The core principle was removing vertical dependence. Instead of holding canvas up with poles, soldiers suspended it from a tensioned ridgeline stretched tightly between two solid anchors such as trees, vehicles, posts or earth anchors. The canvas was then pulled outward and downward with multiple guy lines. Every force was transferred into tension along ropes rather than compression through poles. Wind no longer pushed against a wall. It flowed across angled surfaces, tightening the structure instead of weakening it. The ridgeline was never horizontal. It was set with a slight sag, forming a shallow catenary curve. This shape distributed load evenly along the rope and prevented stress concentration at any single point. Snow weight pressed downward and outward, increasing tension rather than causing collapse. Canvas attached along this line could flex without tearing. Soldiers understood that a tight but forgiving ridgeline mattered more than any pole placement. Canvas was pitched low and asymmetrical. One side faced the prevailing wind and was anchored close to the ground, while the opposite side was raised just enough for access and ventilation. This setup prevented wind from entering and lifting the shelter. Snow simply slid off the angled surfaces instead of accumulating. Unlike tents designed to stand tall, this shelter really embraced low profiles and directional exposure. Height was, sacrificed for reliability. Guy lines were placed at frequent intervals, not just at the corners. This distributed load across many points. Stakes were driven at shallow angles away from the shelter, maximizing holding power. In snow or soft ground, soldiers buried logs, rocks or filled bags to serve as deadman anchors. Each line was tensioned gradually, moving around the shelter repeatedly until the load balanced evenly. This process took time, but once done, the shelter behaved as a single integrated system. Reports from European winter campaigns describe rope and canvas shelters surviving winds that destroyed standard tents nearby. In mountain regions, snow piled harmlessly along sloped canvas, while framed tents collapsed under uneven load. In heavy rain, water followed the canvas outward rather than pooling. Even when canvas sagged slightly as it absorbed moisture, the tension system adjusted automatically. The shelter settled, but did not fail. Rigid tents, you know, would flap violently under the wind, almost announcing their presence to anyone nearby. But with the rope and canvas method, movement was absorbed rather than amplified. The canvas remained taut, which really helped in reducing noise. Low profiles also meant less chance of being visually detected. In wartime, all of this mattered a great deal. After all, shelters that could survive storms but drew attention were, frankly, liabilities. This method, well, it managed to balance durability with concealment quite effectively. No unique hardware was required at all. Rope, canvas shelter halves, ponchos, and improvised anchors, these were enough. 2 soldiers, just the 2, could erect a stable shelter using only what they already carried. Vehicles could even serve as anchor points, and trees became structural assets in their own right. Even in open terrain, buried anchors provided sufficient resistance. The method scaled easily too, allowing multiple canvas sections to be joined for larger shelters without increasing the risk of collapse. The same principles apply to survival shelters, winter camps, and long-term outdoor setups. Replace poles with a strong ridgeline, choose anchors carefully, shape the shelter to the environment rather than forcing symmetry. Pitch low, allow the structure to flex, use more guy lines than expected and adjust them progressively. These steps create shelters that survive weather rather than merely endure calm conditions. Post-war camping emphasized convenience and speed. Pop-up tents replaced skill-based systems. Poles became lighter but no more adaptable. The rope and canvas method demanded understanding and patience, which made it less marketable. Yet it never stopped working. Its decline was cultural, not technical. This method succeeded because it aligned with physics instead of resisting it. It treated wind and load as partners in stability rather than enemies. The shelter did not stand against the storm. It settled into it. That mindset is the true lesson World War II soldiers passed down quietly through experience. If this exploration of wartime field engineering deepened your understanding of reliable shelter design, support in the beginning by subscribing, sharing this episode, and helping preserve serious historical knowledge that still performs when conditions turn harsh.